We're going to go ahead and get this panel started, the importance of data availability. If we can get our panelists up to the couch, and we'll turn it over. Turn it over to Mr. Paul from 𝘐𝘐𝘐𝘕. What you guys going here?
You got it right on someone is with We're rolling. We're rolling. We're rolling. I think one of those up what it is. The grip says.
All right. I'll put this one on.
All right, Ryan, stupid. That's seen. What is it post?
Okay. Can we start? All good? Perfect. Thanks. So I am Paul, head of ecosystem at 𝘐𝘐𝘐𝘕. I will moderate this panel today. First, I will start with an introduction. What is data availability? Because we are like a lot of projects talking about data availability, and I think it's a bit confusing if you're not in this space. So data availability primarily is ensure that all necessary data for validating transaction and state changes is accessible to all network participants. This is crucial in both layer 1 and layer 2. Integrity and enabling solution for maintaining network integrity and enabling trustless verification. So by data availability, we have data availability sampling, data storage, data validation, just data availability in general. So I will let the panelists introduce themselves and what they are doing, what they are building, because we have different verticals on this topic today. And yeah, floor is yours.
Hi everyone, I'm Tian Chen from Polyhedra Network. And we are actually building a zero proof system and decay bridge, especially for bridging messages across different chains.
My name is Nick Pressler. I'm a co-founder of NodeKit, which we are building a decentralized shared sequencer called Syscoin.
My name is Anthony. So I'm the founding partner and also CMO for ETH Storage. So ETH Storage is actually using a storage roll-up to build a storage layer for Ethereum. So in one simple sentence, we are native IPFS for Ethereum ecosystem. So we received 2 grants from Metis Foundation, so one for layer 2 and one for data availability. So very excited to be here and share everything. Yeah.
So as I say, you have like many topics, like with data availability sampling. You have also EIP 4844. You have a big talk in the Ethereum community right now with EIP 4444 that will erase historical data of the node runners to make them more efficient. So with my first question, why is data availability critical for blockchain ecosystem in general, and how does it impact the integrity of a network in your opinion? We want to start.
Oh, yeah, sure. So I think we have been talking about like this word, like DA a lot. Ever since dank sharding has become like very popular. A lot of people actually confusing about this word. So what does data availability means? Basically, DA means data publishing. Using this word may be much better. So after the dank sharding, according to the design, so the block size of the Ethereum will become like 20 size compared with this one. That means they can publish much more data than before, but they're only doing publishing. So after certain days, for example, 14 days for dank sharding, so 21 days for EigenDA, all the data will be abandoned, just threw away. So that's why data storage after that part will be another essential thing, just like what we do. So people always ask me, are you guys doing DA? Are you competing with like Celestia, Dankshard, EigenLayer? Actually, no. Actually, we're working with all the DA solution. So every DA solution, they're responsible for upload the data into some place, especially for the layer 2 data, because they have to upload the data to maintain the security. What we do is we make sure this data will be stored permanently after sometimes when the DA layer will throw the data away. Yeah.
Yeah, I think that's a good introduction. I think some of the interesting things about DA that we're working on right now is the ability to use different layers for different solutions. If one is one of a rollup's preferred DA layer, then they can use anything that is most compatible with that. I also think, like you said, that the separation now of the storage of the data and the availability of the data versus just the actual data availability layer is a unique way to further modularize the industry and step back away from centralizing powers and instead go more down the decentralized route.
I will need to hear again the question, by the way.
I will go again for the question. Why is data availability critical for blockchain ecosystem, and how does it impact the integrity of a network? We are talking like about layer 1, layer 2 mainly.
So why is it important? Because if there is no data availability, pretty much there's nothing. There's no history. There's no way for validators to make sure that these transactions or these blocks should be there. Also, if we're talking about rollups or layer 2s, data availability is 100% key. I mean, they need to store all of these data somewhere. This is exactly why Ethereum has been so big. Ethereum has the longest history, and as we have seen, it takes a long time. Like, it takes maturity for these blockchains or these solutions to be accepted. Just like Bitcoin. Bitcoin has been out there for more than 10 years, and it's now really getting to that adoption phase. And in terms of data availability or just implementing Ethereum for all of these solutions, and eventually for not only the crypto native solutions, but data availability for other newcomers into the industry, we will need to see maturity. And I believe Ethereum is the one that has proven it the most, and others might come along, but this one will for sure be the main place.
Yeah, so data availability, I think it's crucial for most analysis and data analysis applications, I think. And it's crucial for making the blockchain itself as a self-contained thing, right? Without history, it's kind of detached from the genesis, where nobody can confidently join the network again.
Right.
Thank you, guys. I have a quick question. I will try to stick with the panel and not go too far from the question that you received before, but I will go like, still I have a few questions following what you say for sure. Right now we see that on Ethereum it's quite expensive to store data. In fact, like to store 13 gigabytes, I think it's $780 million. Quite expensive in my opinion. On Bitcoin, it's like 35 million. When on other like decentralized storage solution, it's made for, we can have cheaper costs. I think of ETH storage, I think also of Arweave, for sure, or off-chain solution. What is your take on that? Because we see like a lot of debate with Validium of storing off-chain data, and then after having like crypto incentive, like on to retrieve those data. What are your take on that, and what do you think is the best solution to solve this kind of issue?
Sorry, from me again.
Wherever I want to go.
Yeah. Hello. Yeah, I think yeah, everyone knows like store on Ethereum is pretty expensive. It's super expensive. So that's why we have our solution. So our goal is actually trying to reduce the cost of store on Ethereum itself by 1,000 times, while also enlarge the capacity to the PB level. We also work with layer 2, for example, like roll up, decay roll up as well. Yeah. So basically, they're focusing on expanding the transaction per second, but still their storage capacity is not as high as us as well. So that's why they still need a storage layer. So for that part, we can just reduce by 100 times. So people may ask why we need to store more data. So why we cannot just have like transaction data? So if there's only like DeFi, to be honestly, running on Ethereum, it doesn't need that many capacity for a store. But since we have like NFT, GameFi, on-chain GameFi, and if we want to have like more integrated, like complicated, like DeFi, or like the apps like SocialFi, whatever, all those stuff definitely will generate much more data than before. So that's why we have the dank sharding, which will enlarge like more data to be uploaded to the Ethereum. But dank sharding only solve the publishing problem, doesn't solve storage problem. So that's why we have like a backup. So still, if your very important data, for example, like transaction data, you can remain that on the Ethereum layer 1. But for other kind of like, game data, NFT data, all those data, instead of just put that offline totally, we'd better just store on something else. For example, like DA plus storage. That's definitely like a better, terms compared with the offline, the centralized storage way. Yeah.
I think fundamentally, is it going through? I think fundamentally, the reason that we haven't had a lot of innovation in the, or at least decreasing cost of storage or anything relating to the data, is that excellent. All right. So to recap, the fundamental problem with what has been and what should be changing in the future with solutions like e-storage, like any other data availability layer, something else that is touching on data availability, is that you don't get innovation when there's no competition, right? If your only solution is to work with Ethereum or whatever solution that Ethereum has is a solution that you're forced to use, then you're not going to have any incentive structure to improve it because there's no reason to. But things like e-storage or anything else that's working on competing to create a better market for better prices in that industry is going to allow for more users to come on because it decreases the cost of transacting on the platform and increase the innovation because there's more competition in there.
I believe to some extent it's also not a matter of competition. Of course, like you said, healthy competition brings innovation. But to some extent, like we're seeing modular architectures, we're seeing app chains, we're seeing a lot of different variants of like innovation or ways in which people are innovating. And for some of these games or specific blockchains, like it might be the case that, like you said, you made a very great point. It might be the case that some of these won't be stored on Ethereum, but most of these, or like she was mentioning, the DeFi, financial data, all of these pretty much like fundamentals for the industry, or the, let's call it fundamentals, kind of like the actual money that is driving the industry. I do believe it's going to be sitting on Ethereum, or data availability will stay on Ethereum. And for other solutions or other approaches, games, SocialFi, etc., we might see more tailored solutions that might be able to guarantee or facilitate specifically what these platforms are looking for.
Yeah. I've seen actually many interesting applications that require a lot of storage on chain. For example, yesterday I seen a vector database. They were trying to store their database on chain, where each entry of the database is going to cost like several cents. And if you're going to store 1 million entries, that's not even feasible. So I think this is all about. So with more storage, I think it's can enable more interesting, more personalized applications like AI or vector store database or something else. Yeah.
I will try. Is it working? Yeah. Okay, so we have seen that there is like different like approach. Like, what do you feel are the most interesting technological innovation for guaranteeing data availability, and why? And I would love also to jump on that point as 𝘐𝘐𝘐𝘕 and not as a moderator of the panel. At 𝘐𝘐𝘐𝘐𝘕, for those who are not familiar, we are doing a data validity layer. So we are like a pipeline that validates the data in a decentralized way between a data stream and a decentralized storage solution, like if storage, Arweave, or whatever else solution that you want to use. How do you make sure that data that are available first are like true, and you are sure that those data that you are using are correct, because it's a like important point when we are talking about finance, to have correct data to do analytics or like to build product? And what is the best approach in your sense, and that will guarantee that those data are available like permanently, at least for like few years, like let's say 100 or 200 years, based on our wave.
Okay, let me do it. So the most technological advance, I think it already happened more than several decades ago. It was the invention of the error correction code. Most notable one should be LDPC, Polar code, or Rhizome codes. And these are the very basic defense of data availability. And there are other innovations such as RAID or more stable storage media like tapes or disks. I think this is the most important innovation in the data availability area. And actually, as a ZK researcher, we also use error correction code a lot. It's used to protect the data from being tampered by the malicious prover. Yeah, I think that's the most important thing for us.
I must stay a little bit more general. I believe, as I was mentioning before, modular architectures can bring a lot of value to the industry, can be very tailored, and can emphasize on different approaches that builders might be looking for. If I'm old school, if I'm asked what is the way to make sure that data is going to be there in like 100 years, like you said, I would go with my first answer, which is maturity. What have we seen working for many years already? Ethereum. So Ethereum, even though some people might say, oh, it's monolithic, or like might not be the best alternative for everything, I think that as of right now, that is the one that has proven that is the most trustworthy and has been, up for the longest period of time. So I would say what technologies I find fascinating. I would definitely say modular blockchains, modular architectures. How or what would I use, or where would I store data if I don't make sure that it's going to be there in 100 years? Ethereum.
I think there's a lot of value to that, to sticking to where we've been at Ethereum. And I would just second that modular ecosystems going forward are going to both provide now and in the future provide the highest value, or the highest probability of increasing the value that we can have of the projects on chain, just by having, again, the fundamental competition, where you're having the ones that are successful in storing data, the ones that we do see storing data for 100 years as sticking around, and then everyone adapting to that. And I guess maintaining the core tenets of blockchain in general, to be open source, to be decentralized, so that everything that is being innovated upon can continue to be innovated upon, and we're not starting from ground zero again. You know, it's always about building off of what people in the ecosystem have done in the past and continuing to improve upon that.
There has been many interesting innovations in the DA side. One of the grants we received is actually doing data sampling. So what does that mean? So basically, after an attack happens, a robust system can recover from that. So how soon you can recover, which means like the data can be back, was really important. So based on the algorithms we designed, we're actually helping to increase the speed by 3x. So that's something we did, and I'm sure there will be a lot of innovation in the DA side as well.
Thank you. I have still a few questions, one that will be very global, I think, and one where you can talk more, each of you, of what you are doing and what you are building. So can, the more global one, can archiving state-related data contribute to the scalability of a blockchain network? If so, how? Why, in simple terms, why historical data are important for the future of a blockchain? What it brings to the ecosystem to have historical data accessible for everyone and in a transparent and decentralized way? What are the benefits of that? And yeah, if anyone want to go.
I will repeat the question for him if you want to go.
I think beyond, well, obviously there's the answer of you need the data of the blockchain, you know the state of the blockchain in order to continue to operate on the blockchain, right? That's fairly evident. But beyond the storage of data for the use on the blockchain for the blockchain, I think there's a lot of important things around the auditability of the blockchain, where if we want to get institutional adoption, which if there's a bull run to come, I think the object of it should be to get more institutional adoption. We're going to need to be able to prove to them that what we say the blockchain does, it does. That there's a history of it that's more so than just, trust me, here's a proof, this is what it kind of looks like, but actually being able to look at the data, look back on it in a way that we're archiving it instead of just having it as a live state, and being able to look back on it is an important way for the institutions to further become more comfortable with it. I mean, the more data, the better as far as building trust is concerned. So to get that institutional adoption, I would say that having the data backlogged for however long we need it is a good way to build that trust up.
Yeah, I think the whole blockchain, especially Ethereum, is moving from one single blockchain to module blockchain. So nowadays, everyone is talking about like a module blockchain. So we have layer 1, basically for the main transactions, doing like executions. We have layer 2, which we will run like more transactions, right? We have like DA layer, we have storage layer, we have everything. And because we have module blockchain, so that's why we bring like the DA. Previously, so everything running on one single blockchain. So all the data will be stored on the blockchain. It's traceable, it's transparent. That's, you know, the two very important features for the blockchain. But when you have like different layer, like different module for the blockchain, so how do you make sure all the data is still transparent and traceable? So that's why we have like the DA, we have this kind of, you know, design. For layer 2, usually, as we all know, like Arbitrum or OP, they only running centralized sequencer for now. So centralized sequencers, they store the data, but what if like there's like attack happen? What if they just lose some data? And then, so as like a blockchain, you just cannot go back to see what happened as like history, right? So that's why they have to submit the data into the layer 1, which is the DA layer. Yeah, I think according to the blockchain, so it has to be, if it's called like blockchain, it has to be traceable and transparent. Yeah, otherwise it's not like a blockchain.
So just to make sure, like I wasn't able to hear the question that well at the beginning, but I'm guessing the question is alongside how to make crypto or Web3 like trustworthy for institutions.
Yeah, exactly. And why it's important to keep all those data that happened before, like transaction and so on, like accessible and like decentralized in a way.
Okay, so answering the latter question, why is it important? Because we were talking about maturity, but if there is no history, how do we know there's maturity? How do we know if it's been working right? How do we know it's not just being kind of like alive or not working properly? So data availability is essential for just confirming that the blockchain has been working as expected, and for institutions to be able to see, okay, this has been up for many, many years, like it has been running correctly, we can try it out. And in terms, she touched on a very interesting point that was sequencers, like sequencer centralization as of right now, because we are seeing that layer 2s are becoming very important. They are coming up in terms of usage, in terms of adoption. But what happens? A lot of these layer 2s still not only have centralized sequencers, but a lot of these fraud-proof systems, they are still either in progress or they are only for whitelisted verifiers, which is not really decentralized. Like if I'm the sequencer and I can handpick who are going to be these verifiers, is it really decentralized or not really? So this is precisely what, and now jumping in the part in which you say like what each of us are building in Metis, we are taking a strong focus on sequencer decentralization. We are working right now, like should be live in the next few months, a PO, proof of stake, sequencer pool, precisely because we need to make sure not only that the fraud proofs are functional, fraud proofs or validity proofs or whatever you are looking to implement, but only the sequencer decentralization. And how can they also participate or make sure that these sequencers are going to be acting on a good fashion? That's where the proof of stake comes in. And if you want to be able to decide on the blockchain or store data or do any of these important actions, you got to have skin in the game. And there's got to be consequences in which if you act in a malicious way, you will be slashed and you will lost more than you were poised to gain. So that's what I think is going to be very important to make sure these institutions come to Ethereum, making sure that layer 2s are actually secure, that they're actually inheriting the decentralization and the security of Ethereum. And yes, sequencer decentralization is going to be key, but fraud proofs or validator proofs, depending on the approach, will also be key. It's the combination of these two.
Yeah, okay. So imagine that in an ideal world where every single transaction data was preserved in a blockchain, and imagine that 50 years later you talk to your grandson, maybe, yeah, if I have one, that, okay, we co-developed this very good masterpiece. This blockchain has been here running for 50 years. You can verify it. It's all about I think it's all about credit and trust. Imagine that you have data, then you can basically talk to people and say, this blockchain has a 50-year or 60-year of successful history, and the result data. I mean, if you only store 3 weeks of data, people will ask, why do I need to trust this 3-week credit history thing? That's even this thing even don't even have a credit history longer than me, right? I have a credit history of several years at least. Yeah, so I think it's all about trust.
Okay, I will jump also like on more like specific question for each of the project that you are working on, because I think it's also interesting. Polyhedra, if I am not wrong, you are working a lot with Greenfield right now. Like you have worked at least with Greenfield on ZK transmission of those data that are stored on Greenfield to like send them to other app. I am correct? Yeah. Can you explain a bit in detail, because I think it's important. Like with solution like ETH storage, we can store those data. But after how we retrieve those data in a decentralized way to send them to other app for them to use those data and to keep those data decentralized.
Yeah, we actually is building bridges. So Greenfield is one of our actually partner, or one of our target that we connect to. So yeah, we can bridge, we can transmit every single piece of data from Greenfield to every other chain. Yeah, and with almost zero cost. So zero proof enables us very low latency, and with the power of batching in zero proof, you can basically get data in a super cheap way. So yeah, that's what kind of business we do. So we connect different chains or different layers, and I think we are open to everybody. So every storage chain or any kind of chain we can collaborate with. Yeah.
Okay, so you are kind of a data messenger, kind of between chain, data bridge between chain.
Yeah, it's data transmission. I personally usually call ourselves as a network cable between different machines.
Okay, cool. I know that I have checked the news of each of your projects before coming here to be like a bit up to date. So I know also that Metis is proposing a migration to Ethereum mainnet for enhanced data availability, if I am not wrong. Can you talk a bit more about that? And after I will go to NodeKit, because I know that you are working on decentralized share sequencer also. So I think it can be good to have also your point of view of what you talked before, but happy to hear also what you are doing.
Absolutely. So we, on April 2022, Metis went from being a pure optimistic rollup, storing data on Ethereum, to storing data on a distributed storage layer called Memo Labs. This made Metis become the most cost-efficient layer 2, like we had the lowest transaction fees among any layer 2 on Ethereum. But as everything else, it has some trade-offs. So if we, for example, for successfully running fraud proofs or for implementing the proof of stake sequencer pool that we were just talking about, it was not as viable if we retained this approach of having the lowest fees in the industry by storing data on memo labs. So we love having low fees. We love making the network usable and appealing for users. But at the end of the day, if we want adoption, we need to provide security. We need to ensure security and also decentralization. So it's key for us to implement this proof of stake sequencer pool as the very next step. And that's exactly why we are about to migrate data over to Ethereum. The sequencer pool is going to have like different layers. One of those layers is going to be on Ethereum. So we need to have data over there. And well, in terms of the sequencer, I don't want to get like too out of the topic. So that's what we are doing. That's the reason why we are moving back to Ethereum and taking or accepting this trade-off of letting the transaction fees increase a little bit, but being able to ensure security and data availability for the next 100 years, like you said.
Yeah, again, to stay as far away from sequencers as possible here as a decentralized sequencer. Our relationship with data availability is really just through the different DA layers that we allow to integrate in with our platform. Our approach has been, let's let the dApp builders build the dApps. Let's let the coders write the code. Let's let the developers develop. And really, at the end of the day, you shouldn't be unaware of what your data, the best outcome would be to be unaware of what your data availability partner is for your specific dApp. And it only should just work as you intend it to work. So that's kind of our goals for data availability. When you're integrating in with Seek, you send in your transaction and you should have no problem with accessing the data at a later point. That's our approach to it.
Okay, and I have a last question because we are running out of time. So for you, if storage answering, thank you. I have checked your website also, and like we are in close talk because we can obviously collaborate together on between 𝘐𝘐𝘐𝘕 and ETH storage. I have seen that the ETH storage capacity is way bigger than dunk sharding, and like how you are achieving that. What are like how you incentive people to keep those data, etc., etc. Like I think like your approach is quite unique. So if you don't mind explaining a bit more, and yeah, what's coming next for you also?
Yeah, sure. So I think I mentioned this before. So our goal is trying to reduce the cost of store on Ethereum by 1,000 times. And also, if you are using like layer 2, no matter it's decay roll up or OP roll up, so we will bring the cost by 100 times. So that's like the goal. So we work with both layer 1, like Ethereum, DAG sharding directly. We can work with like layer 2 directly as well. If they have their DA designs, for example, like Arbitrum Nova, so it's kind of like a DAC, right? So we can integrate them directly. So right now we're still waiting for 844 to be online, especially for DAG sharding. So it may take some time. But meanwhile, so our integration with Celestia is almost done. I guess maybe this week or next week it should be live. So next step is integrate with EigenDA, Avail, so all the DA solutions. So that's our steps basically. Just like I said, we work with all the DAs. So no matter like which DA you choose, so we're willing to work with you. If you have your own DA solution as like a layer 2, we can integrate with you directly as well. Yeah.
Okay, thank you. So I think we have done we have been around all the question of data availability from like data storage, data availability sampling, EIP 4844, and many other like data availability, data transmission, etc., etc. So I think we have done all the question what we can have. Do you have last word to say, or are we good? Anything to say? Good. Okay, so I think we can have a round of applause for the panelists, and thank you for your time.
Thank you guys. Thank you very much, Paul, for moderating that for us.